Hey guys, hope everybody's doing okay. What we're going to do right now is take a look at the how concentrated is your vinegar titration note sheet. And this is going to be in your lab packet right where you left off after your data collection in the lab in class. We'll go through a very small section of notes, and then we're going to do 3 titration example problems. And once we go through those, you should hopefully use them as a guide to help you figure out how concentrated your vinegar was in the lab based on the data that you collected. So hopefully none of you ended up on the titration board of shame. I'm sure there may have been a few. There always is when it's the first time you've ever done a titration. But hopefully if we end up doing more of these, or if you take AP Chem and we do them, you don't end up on the board of shame. Hopefully a lot of us were there towards the left with the very, very light pink colors with our phenolphthalein indicator. So here's our titration setup, and you're familiar with this from actually doing the lab. And what we did was we took a solution of known concentration, and for us it was the NaOH, the sodium hydroxide, and for us it was 1 molar, okay? And we added that to a solution of unknown concentration until it is neutralized. And the solution of unknown concentration, that was our vinegar. Right? So we wanted to figure out what was the concentration of this vinegar, in this case acetic acid, and we could figure that out by neutralizing it and reacting it with 1.00 molar NaOH, sodium hydroxide. So the solution of known concentration, for us it was the 1 molar sodium hydroxide. That is called a standard, and that is used to determine the concentration of an acid or a base that you're unsure of. The picture on the screen for you guys, it has them using a pH meter instead of an indicator, a color indicator like we used. And in this case, it was a beaker of hydrochloric acid, but it's the same general setup no matter what kind of titration you're really doing. So how do we know when you're actually at that equivalence point for a titration? There's really 2 ways to do it. You can use an indicator that changes color at the equivalence point. So for us, we use phenolphthalein. It changes color at around a pH of 8. Or we could also use a pH meter, which you see on the screen as well towards the right-hand side there. And it's just a little probe that you put in your solution, and it will read a pH on a digital display for you. So we use those in AP Chem for a lab or two, and I use them to test the pH of some of the solutions that you actually make. All right. You could use a range of indicators depending on where you want your equivalence point or where your equivalence point is. So this is one that's bromothymol blue, goes from acidic to basic, yellow to blue. So it's a pretty neat indicator. And here's another chart of more indicators. So phenolphthalein is the one we use in lab. You can see where it is right here. You can see that there are other indicators like crystal violet. It's yellow when it's very, very acidic, and it changes color at a pH of 1. Okay, so if you somehow wanted to know if you have a really low pH of around 0 or 1, crystal violet is the one that you want to use. You don't want to use phenolphthalein to figure out if your pH is around a pH of 1, because once you hit 8, okay, the phenolphthalein is pink, but from 8 all the way down to 0, it's clear. So if you add it to that solution of a pH of 1, the phenolphthalein will be clear. If you add it to a solution of a pH of 6, the phenolphthalein will be clear. So you have no idea if it's a pH of 1 or a pH of 6. So what you want to do is figure out again, where's the pH level that you want to indicate, and then pick a indicator that's going to change color at around that point. Okay guys, let's take a look at some of these titration example problems that you guys have on your note sheet. Here's the first one. This is very, very similar to what you did in lab. So here's the process. You have a 14.3 milliliter sample of acetic acid solution, and that is neutralized with 32.4 milliliters of 1.5 molar sodium hydroxide. I want to know what the concentration of acetic acid is. So here is step number 1. You have to start with a balanced chemical equation. So you have an acid plus a base. That's what your titration is. That's really what all titrations are. Some acidic and basic substance being combined. So here you have acetic acid plus sodium hydroxide to produce water and sodium acetate. This is simply a double replacement reaction, right? Talked about those in our chemical reactions unit. I want to find out what the concentration is of acetic acid. So the first thing I do is write my formula, or my formulas for my chemical equation. Then I balance it. And in this case, it's very easy to balance. Everything is going to be a 1. Okay? Remember, what is concentration? Concentration is molarity. And molarity is equal to moles per liter. So what I need to do here is find out for my acetic acid, because that's my unknown here, I need to figure out my moles of acetic acid. I need to figure out my liters of acetic acid. Well, I already have that. That's the 14.3 milliliters. I just converted it into liters. Okay, so let's go ahead and with this data up here, just like when I taught stoichiometry, let's write it in where it goes in the chemical equation. So 14.3 milliliters of acetic acid, that is 0.0143 liters. And my sodium hydroxide, it's 0.0324 liters, and it's 1.5 molar. Okay, now I unpack that here because 1.5 molar is 1.5 moles per liter. So I'm going to use that conversion factor here when I solve this. So what I need to figure out here is how many moles of acetic acid I have, because if you look at down here in the bottom right hand corner of your screen, I need a molarity, which is moles per liter. So my moles is my question mark. I need to figure it out. So there we go. Look at that. We can go from the data I have on NaOH into acetic acid and figure that out. So all we want to do is use our stoichiometry roadmap, and we're basically starting here at molarity or volume right here. We're starting here, molarity or volume of solution A. In this case, we have the volume and the molarity. Okay, that's the NaOH. I'm going to convert that ultimately into molarity of the acid, of the acetic acid. In order to do that, I need to figure out the moles of acetic acid, which is why I have that as my question mark. So if I have the moles, I do have the volume. It gave that to me as the 14.3 milliliters. Then I could just simply find the molarity based on that. Let's go ahead and do that. Let's go from our molarity and volume of NaOH. Let's go to moles, and let's go to moles of acid and go from there. Okay, let's go ahead and start this. We're going to start with 0.0324 liters of NaOH. Factor label, I'm going to cancel out liters of NaOH and go to moles. Okay, just like I have here. Okay, I want to cancel it out and get to moles right there. Now I need to cancel out moles of NaOH and go into moles of acetic acid. Okay, and let's go ahead and get that, and then I could figure out what my molarity is very easily. So here in this first step, I have moles of NaOH over liters. Well, we're going to use my molarity right here. Okay, so 1.5 moles per liter, and then here's my mole of A over mole, or mole of B over moles of A step, my mole to mole ratio. So chemical equation gives me 1-to-1 ratio, because that's what my coefficients are. I go ahead, type it in my calculator, and I get a number of moles to correct sig figs of 0.049. Okay, so 0.049 moles of acetic acid. So let's find my molarity. Molarity equals moles per liter. That's going to be 0.049 moles over my liters up here for my acid, right? So I want to make sure it matches up here. 0.0143 liters. Go to proper sig figs, and I get an answer of 3.4 molar. Okay, so that's some decent concentration of acetic acid there. Store-bought vinegar is way less than that, and you'll see that because yours was basically store-bought vinegar that you titrate it. We'll see what it comes out to when you do this. So the one that you're going to actually do for your lab is very similar to this. You added a particular volume of acetic acid to your Erlenmeyer flask, and then you titrated it with 1 molar NaOH, and you figured out what your equivalence point was, how many milliliters it took to get there. So you're going to use the same basic process to do yours. Okay, let's go ahead and do a couple more. Let me clear the slide out here in case we need to use the roadmap again. Okay, here's another one. It says a truck carrying sulfuric acid is in an accident. This is very unfortunate. A laboratory analyzes a sample of the spilled acid and finds 20 milliliters of acid is neutralized by 60 milliliters of 4 molar NaOH. What's the concentration of the acid? So chemical equation and formula is what we need here. So I have sulfuric acid, H2SO4, plus NaOH gives us water and our salt of sodium sulfate. Go ahead and balance it. Looks like we need 2 here. Let's see, 1 there, and looks like we need a 2 here. Yeah, that'll work. Okay, so 1, 2, 2, 1 to balance that out. And let's go ahead and put our data here. So we have 20 milliliters of acid. So that's 0.0200 liters. Okay, I have 60.0 milliliters of NaOH. 0.0600. I'm writing it as 0.0600 because that number has 3 sig figs. 60.0 has 3 sig figs. That needs to be consistent. My molarity is 4.0. So that is 4.0 moles per liter. Okay? What's the concentration of acid? So again, concentration is molarity, which is moles per liter. So for the acid, that's what I want to find out, molarity of the acid, I have my liters right here, 0.0200. I need to figure out how many moles of acid I have. Okay, so I'm going to go ahead, go from here to here. This is very similar to the last one, slight little difference though. Let's go ahead and get started. That was liters. Let's go ahead and put our 0.0600 liters of NaOH. Cancel it out. Liters of NaOH on the bottom. Moles of NaOH on top. Mole to mole ratio. Cancel out moles. Go to moles of acid. See what we get. So step right here, first step, I use my molarity because I have moles per liter here. That's going to be 4.0 and 1. Okay, that's just me taking my molarity, unpacking it, using it as a conversion factor. All right, next step is where it's a little bit different. Last time it was a 1-to-1 ratio. This time it isn't. You need 2 moles of NaOH for every 1 mole of sulfuric acid that reacts. Okay, so if you go ahead and plug all that into your calculator, you get a mole value of 0.12 moles of H2SO4. Okay, looks like we're good to go. We have our moles then of acid. We have our liters. Let's go ahead and solve for molarity. Moles per liter. So we have 0.12 over 0.0200 liters. And that gives us some nasty stuff here. That is 6.0 molar acid. Okay? Sulfuric acid is nasty stuff to begin with. I mean, 6 molar is pretty good. All right, it's a pretty high concentration. You can be really, really careful if you were ever to handle something like that. So that's how we take care of this practice problem. So you can see it's the same process. We just really use stoichiometry here to solve these, and we just want to get our moles of acid in this case. The next one's a little different, but it's the same general process. So example 3, last one we'll do, says what volume of 0.1 molar NaOH is needed to neutralize 25 mils of 0.15 molar phosphoric acid. So again, I have the equation for you on the screen. Let's go ahead and balance that. And looks like we need a 3 here. Okay, yep, that'll work. Okay, let's fill in our data like we have in the past. So I have 0.10 molar NaOH. So that's 0.10 moles per liter. All right, I'm just unpacking it like we've talked about a bunch of times. And I have more data about my acid. So in this case, I have 25.0 milliliters. That's 0.0250 liters. And I have a 0.15 molar solution. So that's 0.15 moles per liter. So I'm unpacking my molarity again, as you can see. Now in this case, it says what volume of NaOH is needed to neutralize that. So in the last two examples, like this one, I had to find the concentration of the acid. I had the volume. I had the 0.0200 liters for that one. Here, first of all, I'm solving for something with NaOH, which is the base. Well, that's fine. You're just going to go to a different substance here. But I have the molarity of that. Okay, so I have the molarity of the base, but I don't have the volume. So I want to figure out my volume here. So it's question mark liters. How much of that 0.10 molar solution do I need? So again, we can just really factor label this. Go from here to here. All right. So I have my volume and molarity of my acid. I need to figure out my volume of my base. Start here. I have the volume and the molarity, I have both of those, of my acid in this case. Go to here, go to here. I need the volume of my base, which is this, and I have the molarity. So I'm good to go. So again, you're just going to the same kind of location on the stoichiometry roadmap. Let's go ahead and do it. Let's start out with my phosphoric acid data. I have no choice but to do that. So, like we have been, start with your volume, 0.0250 liters, and let's label it. Let's follow the rules here, of H3PO4. Cancel that out. Go to moles. Okay, let's fill this in, because the next step is going to look a little bit different here, but not too bad. Molarity was 0.15. So that's 0.15 moles over 1 liter. So again, I'm just taking my molarity here and inserting it into my factor label as a conversion factor. Cancel out moles. Let's make this a little bit smaller so I don't run out of room. So we have moles of H3PO4. Convert to moles of NaOH. Okay, from the balanced chemical equation, so 1 mole of H3PO4 right here reacts with 3 moles of NaOH. Okay, so now let's go ahead and factor label the rest of this. Okay, I could stop there and take my moles of NaOH, okay, and plug it into this molarity calculation here. Right, because I have my molarity, it's given to me, it's at 0.10 moles per liter. I have that. I will have my moles now from this stoichiometry. I could then just do algebra and solve for liters, but it's easier to just knock it all out in the factor labeling. Let's go ahead and factor label this then. I want to cancel out moles of NaOH. I want to go to liters of NaOH. Well, guess what? Here in this conversion factor, I have moles and liters. Well, guess what? That's what I have right here. All right, 0.10 moles per liter. Just flipping it, okay? I still leave 0.10 next to moles. I still leave the 1 next to liters. Now you can see everything's canceling out. I'm good to go. So I can just do this all at once, get my answer, and we are in good shape. So type it all into your calculator, and you're going to get an answer in liters, which is fine. It doesn't ask you what the volume should be in milliliters or anything, so just go ahead and solve it, and you get to proper sig figs, which is 2 sig figs. Our molarity here is limiting us. We get 0.11 liters. Okay? That's about it. Okay, so 0.11 liters of 0.10 molar NaOH will neutralize 25 milliliters of 0.15 molar phosphoric acid. Okay, guys? So you've basically seen all the different varieties of problems here you can have. You could either solve for molarity or solve for volume, and you now know both ways to do that. Problems 1 and 2 were solving for molarity, and problem 3 was solving for volume. What you guys are going to do is go to the last page of your lab then, and you're going to want to use your data to complete the titration post-lab questions. So the first one, you're going to calculate the volume of NaOH needed to neutralize your vinegar solution. You're going to use your initial and final volume of the burette to do that. And then you're going to use that as part of your stoichiometry in question number 2. you want to find the molarity of the acetic acid. So write your balanced chemical equation, which you actually have in the lab, and then that's part of your pre-lab, and then fill in your data like I showed you in the first example way back here, and then go ahead and solve for your molarity of vinegar. What you'll do then is compare it to an accepted value, find your percent error, and see how well you titrated. All right, if you have any questions, let me know. That's about it, guys. Thanks.